Integration of dance with mathematics. Objectives: to demonstrate a collective dance rhythm inspired by Bharatanatyam that visually and mathematically represents the circle theorem and rotational symmetry. This evocative image beautifully captures six Bharatanatyam dances arranged in a perfect circle symbolizing geometric harmony and symmetry. Each dancer's position and gesture align with mathematical precision, illustrating angles, axes, and spatial balance. Superimposed symbols like the cone, integral sign, and 90-degree angle emphasize the natural integration of mathematical theorems within classical choreography. Bharatanatyam's structured rhythms, measured steps, and rotational movements reflect core mathematical principles such as proportion, symmetry, and spatial awareness. Together, the photo becomes a live canvas where the tradition and science converge, demonstrating that dance can be a visual experience of mathematical elegance.
Extension. How can we elaborate mathematical focus in the previous image? Creating steps which represents how equal angles subtended by an arc at any point along circumference. Radial and rotational symmetry. Regular polygon geometry like creation of hexagon or pentagon or septagon. And the one of the most impressive feature of dance is its dynamism, where while performing each different mathematical concepts form a beautiful spectrum for the audience. Here is another example illustrating how students can learn dance keeping in mind mathematical interpretation. Initial position: dancers stand on the circumference of a circle, arm extended outward, where arm when extended outward in straight line represents tangents along the circle. Angle establishment: if the arm point at 60-degree interval, then it represents the angle of the angle imposed by an arc along the circle. Chakra moment. All the dancers rotate 180 degrees synchronously, creating six circles or five circles where each center is along the circumference of a common circle. Sequence repeats. Three such rotation creates a full cycle, and then the end pause would be a symmetric star pattern. Now, capturing the dance movement also adds aesthetic to the dance videos. Mathematics can even be applied while considering floor projection for geometric pattern, or focusing on the center spotlight for origin, or taking the photography using drones to mirror circular motions in air. This gives quite mind-blowing visuals.
Assessment and conclusion. Assessment: peer feedback on symmetry. Mapping dance paths on graph paper. Quizzes on geometry link. Conclusion: this fusion natures logical reasoning and cultural expression in line with NEP 2020's interdisciplinary vision.